We're going to answer this question before us. It says, a spinner with 3 equal sections colored red, white, and green is shown below. The spinner is spun and a fair coin is thrown simultaneously. Draw a tree diagram below to represent the possible outcomes of the experiment. Okay, so what are we doing here? We're spinning a spinner, which is either red, white, or green. That one. Whoopsie daisy. That one. Then from each of these, we're either getting a head or a tail. A head or a tail, a head or a tail. And it's useful here just to think about the probabilities of each of these as well. Because they're all equal sections, that means there's a 1 on 3 chance of getting either of the colors here. And then, because you've got a 50-50 chance of getting a head or a tail, there's a 1 on 2 for each of these. Now, when it says list the outcomes that form the sample space for this experiment, that is simply going to be the following. You could either get a red or a head, or a red and a tail, or a white and a head, or a white and a tail, or a green and a head, or a green and a tail. Okay, we continue on. Let R represent the event of the spinner landing on red. Let T represent the event of a tail appearing. Okay, so we've got this. What's the probability of getting a red intersection of a complement of T? So anything but a T. The trick with this is recognizing what this means. This means anything but a tail. And what is the only opposite of a tail? So what's the only alternative to a tail? It's a head. So it's just the probability of getting a red and a head. That's all it is. And that means you need to know how to read off your tree diagram here. So to read off your tree diagram here, you simply multiply across the branches. So you multiply across the branches here. So that means here, that is the probability of a red intersection of a head, which is going to be 1/3 times 1/2, which is 1 on 6. So 1/3 times 1/2 is 1 on 6. Another way you could answer this one is simply going, well, when do you get both a red and a head? Well, the only time you both get a red and a head is right here. That's the only one. Now, you have a total of 1, 2, 3, 4, 5, 6 options, and one of them works. It's 1 on 6. So you could have just used your sample space to answer this as well. That's a viable alternative. Okay, let's now answer the next one here, which is a union question. So the probability of R complement, the union of T complement. Now, this one's a bit trickier because what you'd have to do to answer this is use your addition rule. Remember, your addition rule tells me that the probability of R dash plus the probability of T dash is going to be minus the probability of their intersection is going to be equal to the union. This one, intersection of that one. That right there, everyone, is the addition rule. Okay, what is the probability of R dash? So that's the probability of getting anything without a red. So the probability of anything but a red. So we can come up here and we can say, well, anything but a red would be 1, 2, 3, 4. 4 on 6. So we can come there and we can put 4 on 6 here. Then we want to figure out the probability of anything but a tail. So that means all the head options. So that would be head, head, head. 1, 2, 3. It would be 3 on 6. And then we want to get the probability of R dash intersection of T dash. So that is the intersection of everything that is not red and everything that is not a tail. So you could use your sample space here again and say, all right, I want to underline everything that isn't a red and everything that isn't a tail. So that's going to be a white head or a green head because everything else either has a tail or a red. So that's going to be 2 on 6 because there's 2 out of a total of 6 there. So minus 2 on 6. There is another way to get that one here. So to get that 2 on 6, it's not very quick. The other way to do it is to come up here and say, all right, the other way you can think about it is to say, well, let me grab a blue here. We could say, well, what is the probability of W intersection of H? That will be 1/3 times 1/2 is equal to 1 on 6. What's the probability of getting G intersection of H? Because as you can see, we're just getting everything that isn't red, so W and G, and then H and H, everything that isn't a T. And then we're doing that. It will be 1 on 6. And then you would add both of these together to get 2 on 6. It's a lot longer, isn't it? not really needed, especially if you can got your sample space there and you can kind of think it through. It is important that you can do both ways, but you can kind of see that one is clearly easier than the other. Okay, then once we're here, it's just a matter of adding. All right, let's not make any silly mistakes here. Silly mistakes are my kryptonite. 4 plus 3 is going to be 7. 7 minus 2 is going to be 5. So it will be 5 on 6. And just like that, that's our answer. So hopefully you were successful with this question. There's our answer there. There's our answer there. I'll see you in the next one.